So hi guys, welcome to the biochemistry class. My name is Akshay. In previous video we have seen the monosaccharides, how different structures of monosaccharides. Today we will see in this video the disaccharides. What are disaccharides? What are different types of disaccharides? Okay, so disaccharides are basically two monosaccharides attached through a glycosidic bond forms a disaccharide. Okay, so here I have seen written here the two monosaccharides units attached by a glycosidic bond will form a disaccharide. Okay, so the first example of disaccharide is maltose. Okay, so the maltose is a disaccharide of alpha D glucose and beta D glucose. Okay, so we will first see the structure of maltose. So alpha D glucose, how it looks. Okay, as I said, alpha H OH. Okay, this is alpha D glucopyranose. Okay, this gets attached with beta D. OH will be up. Okay, this is beta D glucopyranose. Okay, here this is the first carbon, anomeric carbon. This is the first anomeric carbon. This is the fourth anomeric carbon. So in this case, what will happen? There will be condensation reaction. H2 will be released. How it will be released? This OH and this H, okay, will be removed. Okay, and this bond will form between first carbon of alpha D glucose and fourth carbon of beta D glucose. So what will be the structure? Okay, H O just structure will be as it is here. Okay, so this is beta H OH, okay, so this is the first carbon, this is the fourth carbon of beta D glucose. So there is a bond, glycosidic bond will get formed in first carbon of alpha D glucose and fourth carbon of beta D glucose. Okay, and this glycosidic bond can be hydrolyzed to form two monomers, monosaccharides, through hydrolysis if H2 is added. Okay, so what will be the name of this compound? It is named as alpha D glucopyranosyl. Okay, 1,4. One first carbon here of alpha D glucose and fourth carbon of beta D glucopyranose. Okay, so beta D glucopyranose. Okay, so this is how it is named, alpha D glucopyranosyl 1,4 between first and fourth carbon so it is given as arrow 1,4 beta D glucopyranose. So it is also called as the maltose. Okay, this is how maltose is formed. So if you look at the structure of a maltose, what happens here, this anomeric carbon is involved in glycosidic bond of alpha D glucopyranose, but this anomeric carbon of beta D glucopyranose is free. Okay, so it can form another glycosidic bond with another glucose or any monosaccharide. So this has a reducing end. So this has a reducing end. Okay, so maltose is a reducing sugar. Okay, it's also called a maltose is reducing sugar because it has one anomeric carbon which is free to form a glycosidic bond with another glucose or any monosaccharide. Now we will see the another monosaccharide, which is lactose, which is present in our milk. Okay, so whatever the milk we add in tea, coffee, there is lactose is there. So the lactose is a disaccharide which has two monosaccharide units. One is beta galactoside and another is beta glucose. Okay, beta galactose and beta glucose. So we will draw the structures here of lactose. So first we will draw beta galactose. Okay, so OH is up, so this is beta D galactopyranose. Okay, so it is attached with beta D glucose. Okay, so this is the first anomeric carbon of galactose, this is first carbon of glucose, this is fourth carbon glucose. Okay, this is beta D glucopyranose, right? So there will be condensation and this OH will get removed, right, and there will be formation of glycosidic bond. So it will look like this. There will be there will be oxygen H. Okay, so this is galactose. Now it forms bond with glucose, which is beta. So there is a formation of bond between first carbon of galactose and fourth carbon of beta D glucose. So what will be its name? Beta B galactopyranosyl 1 4. Okay, first and fourth carbon, 1,4 beta D glucopyranose. Okay, this will be named, and it is also called as lactose. So this is how the lactose is formed between galactose and glucose. So as in case of maltose, it is also has a free anomeric carbon. This is carbon number 1 in beta D glucose, so it has a reducing end. So lactose is reducing sugar. It is also called as reducing sugar because it has one end which can form glycosidic bond with another monosaccharide. So this is how lactose is formed. So now we will see the third disaccharide, which is a sucrose. Okay, it is a table sugar, and we add this in tea and coffee as well. Okay, our normal sugar. So sucrose is a disaccharide which has two monosaccharides, which are alpha D glucose and beta D fructose. Okay, so glucose and fructose. Okay, so we will see their structures now, how it is formed. So this alpha D glucopyranose and another fructose. It will be beta D fructose. Okay, so this is beta D fructofuranose. Okay, so in this formation of glycosidic bond between alpha D glucose and beta D fructose, these anomeric carbons will be involved in the formation of glycosidic bond. Okay, so how it will form? This OH will be removed here. Okay, so for that this structure has to flip. Okay, so this fructose will flip, it will be like this. So how it will look? So there will be release of water. Okay, and this is okay. So as this structure will flip, okay, so everything will flip. So the OH will be down, HCH2OH will be up. Okay, then HOH, OH, and this will be OHH. Okay, then HCH2OH, that will also flip. So this is how the glycosidic bond will be formed between the anomeric carbons of alpha D glucose and beta D fructose. So in this case, in the sucrose, both the anomeric carbons are involved in the formation of glycosidic bond. So what will be its name? Its name will be alpha D glucopyranosyl 1 double arrow 1. Okay, so we are giving double arrow because both the anomeric carbons are involved. So one double arrow will be there, one carbon. Beta alpha D glucopyranosyl beta D gluco fructofuranoside. Okay, it is named as furanoside because it is a non-reducing sugar. Okay, because both the anomeric carbons are involved in glycosidic bond, so there is no any, and both sides there is no any anomeric carbon left to form the glycosidic bond. So this sucrose is a non-reducing sugar. It is non-reducing sugar. Okay, maltose and lactose are reducing. Okay, this is non-reducing, so non-reducing end. Okay, it has a non-reducing end, so it is sucrose is non-reducing sugar. Okay, so this is how sucrose is formed from glucose and fructose. So that's it for the disaccharides. So if you like this video, please share it with your friends and subscribe to my channel, and I will see you in the next video. Thanks for watching.